Welcome to the session number 8 from the chapter of electromagnetic waves. The topic is the properties of electromagnetic waves, and this session is in continuation of the session number 7. So in this session we will be discussing here 6 important points with respect to this property of electromagnetic waves. And the first point here is that the intensity of the electromagnetic wave is equal to epsilon naught into E square into C, or it will be equal to epsilon into E square into V. Now this formula is valid when the wave is traveling in free space or vacuum, and this formula is valid when the wave is traveling in some other medium apart from the free space or vacuum. Now in terms of the magnetic field, the intensity of the electromagnetic wave is equal to B square upon mu naught into C. This formula is valid when the wave is traveling in the free space or vacuum, and this formula, that is B square upon mu into V, this is valid when the wave is traveling in any other medium apart from the free space or vacuum. Now in terms of the peak values of the electric and the magnetic field, the intensity of the electromagnetic wave is equal to 1 by 2 into epsilon into E naught square into V. This is valid when the medium is other than the free space or the vacuum, and this intensity of the this electromagnetic wave in terms of the peak value of this magnetic field, this is equal to 1 upon 2 mu into B naught square into V. Now this is valid when the medium is other than the free space or the vacuum, and this formula, that is 1 upon 2 epsilon naught E naught square into C, or B naught square into C divided by 2 mu naught. These two formulas are valid when the medium is free space or vacuum. Now the RMS value of the electrical field is equal to E naught upon root 2, where E naught is the amplitude of electric field. Similarly, the RMS value of magnetic field is equal to B naught upon root 2, where B naught is the amplitude of the magnetic field. I is directly proportional to the square of the peak value of electric field, and I is inversely proportional to the square of R, where R is the distance. So these are the 3 important points. The next important point is that the intensity of the electromagnetic wave in terms of the energy density, this is equal to U into C when the wave is traveling in free space or vacuum, or U into V if it is traveling in some other medium apart from the free space or vacuum. The refractive index of a medium is equal to under root of mu r into this epsilon r. Mu r is the relative permeability and epsilon r is the relative permittivity. The absolute refractive index of a medium is equal to C upon V, where V is the velocity of the wave in the medium and C is the velocity of the electromagnetic wave in free space or vacuum. Now the velocity of the electromagnetic wave is equal to 1 upon under root of mu into epsilon, where mu is equal to mu naught into mu r, and epsilon is equal to epsilon naught into epsilon r. Here mu naught is the permeability of free space, and epsilon naught is the permittivity of free space. Mu r is the relative permeability, and epsilon r is the relative permittivity. And here mu is the permeability of a medium, and epsilon is the permittivity of a medium. So, and here C, because for the free space this epsilon r and mu r is equal to 1, so the velocity, or you can say the speed of the electromagnetic wave in the free space of vacuum, this will be equal to 1 upon under root mu naught into this epsilon naught. Now the momentum which is delivered to a perfectly absorbing surface by the electromagnetic wave, this is equal to U upon C or U upon V, depending on the medium in which it is traveling. If the medium is free space, then it will be equal to U upon C, and if it is some other medium, then it will be equal to U upon V. And the momentum delivered to a perfectly reflecting surface, this will be equal to 2U upon C or 2U upon V. Again, it will depend on the type of the medium in which it is traveling. 2U upon C will be when the medium is free space or vacuum, and 2U upon V will be when the medium is it is any other medium apart from the free space or vacuum. So in the next session we will be discussing about the Poynting vector, which is a very important topic from the chapter of electromagnetic waves. So till then, have a nice day. Bye.